Hello students, in this video we will discuss regarding the transportation problems. Now what are transportation problems first of all? Transportation problems are an LPP type of problem in which our basic purpose is to send the quantities at various destinations but at a minimum possible cost. So whenever minimum type questions have been given to you, like in the form of costs, losses, we will try to minimize that. And if the maximization questions have been given, we will have to convert the problems into the minimization problems and then we will solve it. So basic aim for solving the transportation problems is to calculate such combination between the routes and the destinations so that overall transportation cost is minimized. So now we have algebraically different methods to solve the transportation problems. First of all, we will discuss regarding the initial feasible solution of a transportation problems with the help of three methods. First one is north-west corner method. Second one is least cost entry method. And third one is Vogel's approximation method. So by any of these three methods, we will first find out the basic feasible solution. And once we will reach at the basic feasible solution, we will try to test the optimality of these solutions. Whether the values that we have found with the help of initial feasible solution are optimal values or not. And that we will do with the help of two tests. You can apply either of two tests. First is stepping stone method and second is Modi method, that we call in short Modi. These methods we will discuss in detail now. Now let's first of all start with the initial feasible solution methods. First method we will discuss is north-west entry method. Now north-west corner method, it is the most simple method to calculate initial feasible solution. Here we will start with the northwest corner and then we will solve the initial feasible solution of a transportation problem. Now let us see one example to understand this method. Now in front of you, you have one transportation problem and that has to be solved with the help of northwest corner method, and we call this method the short form NWCM also. So see, like this transportation problem will be given. It means if you have to move from X1 to W1, then you have to bear 19 rupees cost. And if you have to move from X2 to W1, you will have to bear 70 cost. Now we have to find out which destination should be covered with which mode of transportation so that overall cost is minimized and every destination is covered by the different transportation modes. Now on this side we have been given the requirements and on this side we have been given the capacity. Like this we can be given supply and demand also. So first thing you have to do is you have to check whether it is a balanced transportation problem. So you will be calculating the total of the capacity as well as the requirement. So as I can see, the total of capacity is coming out to be 34 and from this side also it is coming out to be 34. So it means it is a balanced transportation problem and we can start just applying the northwest corner method. If it is not balanced, generally we balance it with the help of dummy. Wherever the amount is getting less, we just introduce dummy. So first step is we have to just calculate the values of transportation cost which is minimum. So now let us just put the boxes over these transportation costs. Therefore, to just solve the question with ease, we have just put these values into these boxes. Now let us see how we will start. We will start with the first northwest corner. The inside first corner you are going to start. Now you will observe in front of that what is the capacity given? 7. And what is the requirement? 5. So maximum we require 5 but we have the supply of 7. So we will just put a 5 over there. You can just remember whichever is minimum, or you can understand if we require 5, whether the supply is more, we require 5 only. So we are putting 5 over here. If you put 5 over here, now this requirement has been met. So we will put it as 0. This requirement has finished. And on this side, out of 7, we have already given 5. So we will be left with 2. So how much is left? We will write over here. So once any row or column is utilized fully, that will be deleted. Now I can see in this row still 2 are there, but in this column I have given it a 0. So I will delete this. You can delete this with the help of a pencil or you can delete this in your mind. That is the thing required, that we will not give any other rims now in this column because 5 has finished. Now again we will find which is our northwest corner. Now our corner is this. The inside most corner is 30 now. Now in front of 30 we have 2 availability while we require 8. So if I have only availability of 2 units, I can give only 2 whether the requirement is 8 or not. So if I have given 2, now it will become 0, fully utilized. In front of this, out of 8, 2 requirement has been met, so 6 requirement is still left. So now I will again observe my this row and this column, this has become 0. So I will just delete this row because maximum supply has already been given to this box. Now next step, again I will find my which is my northwest corner. Now this has been deleted, this has been deleted, this is the corner that is most inside. Now in front of this I will see my requirement and supply. Requirement is 6 while the supply is 9. If supply is 9 but I require only 6, so I will put up a 6 over here. Now with this remainder will be 3 and here 6 requirement has been met. So now this column has become 0. We will delete this column. Again I will find my corner. Now this is the corner I can see. In front of this capacity is 3 while the requirement is 7, but I am capable of supplying only 3 units. So I will just delete this 3 and this will be converted into a 4. So now if this has become a 0, I have to delete this row. Now I am left with only these 2. So this is my corner. So in front of this 4 is the requirement while the availability is of 18. So I can give here only 4. So again I will delete this. It will become 0 minus 4. It will be 14. Now I have to delete this. I am left with only one box, and in the last you will see on both the sides you will have same value. This is why, because we have initially checked whether the requirements are equal to capacity or not. So this 14, I will just put a rem of 14 over here. This will become 0, this will become 0. So all my rows will be deleted, all my columns have been deleted. So after this, what will I do is, so here I have already reached at my final feasible solution as all the requirements and the capabilities have become 0. So now we have to write the answer. How we will write the answer? First rim was allotted 5, so 19 into 5, it is the cost if we are transporting X1 from W1. So this is how we will calculate the minimum transportation cost. So now this is how we will be writing the transportation cost in the last. So we will write that to W1 and W2 and X1. W1, X1. So wherever rims have been assigned, we have to write that. First of all, this rim was assigned. So we will write W1, X1. So, and what is the transportation cost in this? So we will write 19 into 5 is the transportation cost of this cell. So this will be 95. Second rim has been assigned X1, W2. So W2, X1. And what is the cost of this? 30 into 2. So we will write like that, 30 into 2, that is 60 rupees cost is there. Then the third I can see in X2, W2, X2, 30 into 6, that will be rupees 180. And fourth X2, W3, so W3, X2, it will be 40 into 3, that is 120. Next I can see is X3, W3. So W3, X3 value is 70 into 4. That is amount is rupees 280, and the last is W4 and X3. So X3, W4. W4, X3, and the cost is 20 into 14. That is 280. And we are going to add these amounts. This is the cost, so it will be in rupees, minimum transportation cost, and we will add these now. It comes out to be 1015 rupees. So this is the minimum transportation cost that you have to bear, and with the help of northwest corner method we can calculate the assignments, or we can say the rims allotted to different transportation destinations. So now in the second part of this video we will discuss the case where the capacity and requirements will not be equal. Now let us take another example in which the dummy will be introduced. Now this is another practical question in front of you. Now in this you can see, as we have earlier done the previous question, it looks like similar only. These are the transportation costs given for individual cells. If we want to go from W1 to X1, rupees 11 will be charged. Now first step I told you in the previous question was you have to see supply and demand requirements, and capacity should be, total should be same. So if I total this supply column, this comes out to be 76. And if I just total this demand, this comes out to be 71. It means now on this side, demand side, 5 have been less. So what we have to do is we have to put an extra column over here. You can put one extra column over here, and that 5 is required, so that once you put it 5, it comes out to be 76. So wherever it is less, if it would have been less on the supply side, I would have introduced one row. Now this we have introduced ourselves, so that is why it is called a dummy column, W4, which is dummy. So we will allot, because this does not exist in reality, it means it has cost 0. We are just doing it to make it a balanced problem, as it was an unbalanced problem. So now again I am going to apply the north-west corner method that we have already done. We will start with the first corner. Now this is my first corner. So in front of that, 14 supply, 18 demand. So I can only supply 14 units. With this will become 0. Here demand of 4 will still be left. So by this I can delete this row, as the total has already become 0. Now I'll come to my next corner. I can see this has been deleted. So this is my next northwest corner. So in front of this, 4 is the demand, 26 is the supply. But if demand is only 4, I can't supply more than that. This will become 0 and this will become 22. So now this has become 0. So I will be deleting this column, as its total has already become 0. Now I will search for my next corner. This is the next corner. This has been deleted. This has been deleted. In front of this, 22 supply, 28 demand. So 22 minimum. So this will become 0, and here 6 will be left. Now with this my row will be deleted. Now this is the corner that is left. In front of this 6, and here it is 36. So 6 can be allotted. So by this is going to be 0, and this will become 30. So if this has become 0, I will delete this. Now I am searching for my next corner. This is the next corner. In front of this, 30 and 25. So I can allot 25. This will become 0 and this will become 5. So now if this has become 0, this will be deleted. Only this dummy column is left. Now this is the corner. And this rows have already been deleted. This only cell is left. In front of that, 5 and 5. Because we have already made it a balanced problem, so on both the sides same value will be left, 5. So with this has become 0 and this has become 0. So it means when all the values on both the sides are 0, it means the initial feasible solution have been found. Now we will just write this answer as we have written in the previous question. So now we will write the transportation cost that we got from these cells. First cell we got is W1 X1. Transportation cost is 11 into 14. That is 154 rupees. The second cell we got is W1 X2, and the value is 7 into 4. It comes out to be 28. The third cell is W2 X2, and its value is 17 into 22, and this comes out to be 374. The next cell we got is W2 X3, and the values are 23 into 6. It comes out to 138. Next cell we got is W3 X3, and the values are 21 into 25. By this multiplication we get 525, and the last I can see is dummy and dummy X3. So we can write here DU X3, and the values are 0 into 5, so it will be 0. Now we will total this out and calculate the total minimum transportation cost, which comes out to be 1219 rupees. So this is how we will calculate the questions with the help of first method of initial feasible solution, that is northwest corner method. In the next video, we will see the explanation of least cost entry method. Thank you.